So let's talk about word problems that involves rates and unit rates. So just a quick review. A rate is a ratio that uses different units of measure. Now, a unit rate is a comparison of one unit or one quantity to another quantity. So usually we use the word per, which means for every. For every. Now, the word for every separates those two quantities. And some common unit rates: miles per gallon, cost per pound, miles per hour, and earnings per hour. Equivalent rates means they have the same unit rates. Make sure you watch a previous video about rates and unit rates. Now, let's do our first problem. It says, example 1, finding the unit rate. So 5 large cans of spaghetti sauce weigh 15 kilograms. So we're comparing two units. The rate is the 5 large cans of sauce weighs 15 kilograms. The question is, or the task is, find the unit rate of kilograms per can. Now remember, when we write our rates slash our ratios, order matters. It mentioned here is kilograms first. Per can, right? So that means we need to get 1 can for every can. How many kilograms are there? kg shortcut. So how many kilograms are there of spaghetti sauce for every 1 can? Now, what's the rate? The rate is 15 kilograms for every 5 large cans. So 15 kilograms in 5 cans. And what we're trying to find is find the unit rate of kilograms per can. So don't forget, order matters. So how did we get 5 to become 1? We're dividing by 5. Remember, to get the same equivalent rates, we need to divide or multiply by the same number. Or this is just saying 15 divided by 5, right? And that gives us exactly 3 kilograms for every can of spaghetti. So that's number 1. Now, number 2. Determine which brand is a better buy. When you say better buy, when you go to the store, which one is the cheapest? That means you save money. So which one of these two brands, brand A and brand B of toothpaste, is cheaper? Well, it's a better buy. So remember, our units would be in dollars and in ounces. So let's compare their rates. So brand A, the rate would be $2.64 in 6 ounces. And brand B says $3 and 60 cents for 8 ounces. Now remember, to compare the rates, it's easier when we get our unit rates. So this is 1 ounce. So for the same amount of ounce, how much does it cost? Which one's cheaper? So use your calculator and solve it. Pause the video. After you're done, play it again. All right, so I guess you're done solving. So this is going to be $2.64. We divide by 6. And you would get how much? Yep, you would get 0.44 cents. It's 44 cents per ounce for every ounce. How about brand B? $3.60. We're dividing this by 8. And you will get, exactly, it's 45 cents, right? So which one's cheaper? Yep, brand A is cheaper. So you're going to say brand A is a better buy. And we always compare prices when we go to the supermarket. Now let's do example 3. It says here, determine which car gets a better gas mileage. What does a better gas mileage mean? It means more miles for less gas, right? Or the same amount of gas, but you travel more miles. More miles for less gas. So is it car A or car B? So let's get the unit rate. So the two units of measure we're using will be the miles for distance and the gallons. Okay, so car A, it says 234 miles. Oops, there you go. In 9 hours. Oh, no, not 9 hours. I'm sorry, 9 gallons. And car B has, that's car A and car B. So has 140 miles for 5 gallons. Now let's solve our unit rate. Let's compare unit rates. I'm gonna use red. So for in the same amount of gallon or same amount of gas, who can travel the furthest? Or who will have more miles? Which car would have more miles? That would be, ta-da-da. So we're dividing this by 9, we're dividing this by 9. 234 miles divided by 9, you will get 26 miles for a gallon. How about car B? If we're dividing this by 5, because 5 divided by 5 gets you 1 gallon, so 140 miles divided by 5 will get you 28 miles a gallon. So which car would you want? A car that can give you 26 miles a gallon of gas, or a car that can give you 28 miles for a gallon of gas? And I would go for B. So car B has a better gas mileage. Okay, that should be, let me erase this part. Let me write this properly. Mileage. Da-da-da. Mileage. There you go. Done. Now let's do the last example. Example 4. Using a unit rate to solve a rate problem. So what information do we know? A hiker walks 20 miles in 8 hours. So a hiker walks 28 miles in 8 hours and is happy walking. There you go. First question, how many miles does the walker walk per hour? So what's our denominator? The hour. So our denominator is 1 hour. That means we're looking for how many miles? Good. So it's always nice if we can organize our data. So we're looking for the number of miles for 1 hour. But what do we know? We know that the hiker walks 20 miles in 8 hours. So how do we get the unit rate? We're just dividing by the same number, which is divided by 8. We divided by 8. Why 8? Because 8 divided by 8 will get you 1 hour. So 20 miles divided by 8 will give you 2.5 miles. So the hiker walks 2.5 miles in 1 hour. Now, let's do part B. Part B says, how many hours, so hours is mentioned first, does it take for the hiker to walk 1 mile? So hours is mentioned first to walk 1 mile. So what we're looking for would be the number of hours in 1 mile. Order matters. Always remember that. Order matters. So hours is at the top, miles is at the bottom. Now, what do we know from the top information? So the hiker walks 20 miles. So the 20 now will be your denominator because it says in miles. That's how important the units of measure is in labeling your rates. And the hours would be 8 hours based from the information. Okay, so these numbers right here follows the units of measure. Don't forget that. Now, how do we get from 20 into 1 mile? We're dividing by 20. So 8 divided by 20, that should give you, 0.40 hours or 40 hundredths hours per mile. Now, how many minutes would that be? So all you need to do is just multiply 0.40 times 60, and you would get about 24 minutes. So that's part B. Remember, order matters. Let's do part C. Part C says, how many miles does the hiker walk in 3.5 hours? So based from our previous information, we know that the hiker walks 2.5 miles in an hour. So we're going to use this information to answer this problem. Okay? Why? Because if you make sense of the problem, it says how many miles, does the hiker walk in 3.5 hours. So we're looking for the number of miles when the hiker walks 3.5 hours. So using the information that we know from the previous solution, we know that the hiker walks 2.5 miles for every hour or 1 hour. Now, why do we use the unit rate? Because it's easier to transition from 1 hour to 3.5 hours, right? So what did you multiply to 1 to get 3.5? We multiply by 3.5. So again, to get equivalent rates, we multiply the same number to both the numerator and the denominator. So 3.5. So what's 2.5 times 3.5? And you would get, if you use your calculator, 8.75 miles. So the hiker walks 8.75 miles in 3.5 hours. Okay? Make sure you make sense of the problem. Now, problem letter D. How long does it take the hiker to walk 8 miles? So how long is the time first, then the distance next? So our information would be the top, your numerator would be the time in hours because it says how long, right? Does it take the hiker to walk 8 miles? So from the information at the top, which one should we use? Yep, we should use letter B answer, which is 0.40 hours in 1 mile. Why? Exactly, you're right, because it's easier to transition from 1 to 8. How did 1 mile become 8 miles? We multiply by 8. So the same goes for the numerator. So 0.4 hundredths or 40 hundredths times 8, or 0.40, make it easier to say. So 0.40 times 8, that will give you how many hours? Yep, it's gonna be, let me highlight this for you. So this will be 3.2 hours. So in 8 miles, the hiker walks for 3.2 hours. So always make sure to make sense of each question, each problem, okay? And then you can manipulate the data, the rates, and the unit rates. Hopefully that helps.